So in this section, we would be looking at how to visualize or recreate the entire step turning process on lathe using CNC Simulator. So first, we would just have a look at the process. Here is the image of a cylindrical workpiece, which has 32 mm diameter initially, and it has got a total length of 150 mm. After the turning process, it looks like this. So we will do this in the CNC simulator. This is how the simulator actually looks like. We have got few options over here. First, you would just click on screen and click on turning so that we will be able to do this turning process. In this blue screen here, we will actually be writing all the code that goes in for the process. Before that, we will click on simulate and specify the geometric parameters of the workpiece. Go to detail settings and the diameter, it's 32 initial diameter. The length we specified as 150, but while we are doing this process, we have to make sure that there is some extra length added to it. So we'll just write in 200 mm. And yes, the dimensions are in mm. So actually, when you start this simulator for the first time, you will get to see a dialog box asking you to choose between units. You can choose mm or inches as per your requirement. Here we'll make like keep it as diameter coordinates and nothing to change much. Just click on origin at end face, and this allows us to locate the origin at the center of the circular end face, and that's it, and click on OK. Now go to edit and automatic line numbering and make both one. So this actually specifies how we would write, I mean, start writing the code. So start number one means the lines will start from one, and increase value one means the difference between the numbering of each line would be one. So it will go like N1, N2, N3, N4 like this. We will see this now. So click on OK, and here you have the first line N1. Before we start doing the process, we must specify the coordinate system. In CNC Simulator, there are two coordinate system. Basically, the first one is absolute coordinate system. So in absolute coordinate system, you have the origin fixed at a given point throughout the process. And the another one is incremental coordinate system. In incremental coordinate system, what happens is, as you're doing the process, the location of the origin changes to the previous location of the pointer. So we would see the incremental thing later on. Let us just focus on absolute coordinate system for time being. So let me just show you all the code that is required here. So there are some terminologies here, G codes and M codes in the CNC simulator. So you can look over here. G codes control the movement of the CNC machine, and M codes, they are responsible for some secondary or auxiliary functions of the CNC machine. So we would have just have a brief look at it. And okay, so in order to make sure that we are in the absolute coordinate system, we would type in G90, and then we would type G71. G71 is used so as to specify that in every pass while we are doing turning operation, there is some material removal. So if you want to have material removal, you have to type in G71. Then G94. G94 goes in for specifying the feed rate of the tool, and we would type F100. So as we have already selected mm as the unit, F100 means the feed rate of the tool is 100 mm per minute. Okay, so in the next line, we would actually want that the locator or the cursor is placed at the origin. So the code for that is G28. G28 allows us to locate the, or position the cursor at the origin or at any location. So the origin would be x0, y0, and z0. G28 only used for absolute coordinate system, so keep that in mind. And then next is third line. On the third line, we'll specify the tool that we'll be using. So the code for it, that is M06. M06 is used to specify the tool, and we have tool numbers like T01, T02, and so on. So we would just type in T01, and then we want to specify the the fluid or the coolant that will be used for lubrication purposes. So let us just have a look at it. Here is the code. Here is a list of the M codes. So here M06 is for tool change, M07 is for mist coolant on, and M08 is for flood coolant on. So these are two types of coolant that would be used in the process. We would just click on M08. So M08 will allow, a better cooling action. And yes, and M05. So we would also need to turn on the spindle, and the code for that is M05. And yes, uh, I'm sorry, this is for stopping the spindle or turning the spindle off. In order to turn the spindle on, we have two things. First is M03, which is for clockwise. We would just go with M03 for time being. So having done with this, let us just have a look at the code first. Um, after this one, we will just go to was so moving on. The next line would actually start the process. So there are two things here. The first one is G00. G00 will rapidly locate the tool from one point to another point. So let's say initially you have kept the tool at origin. Initially it was at origin x0, y0, and z0. So if you type in G00, it will rapidly reposition the tool from the origin to the point you specify in this line. So let us type in x32. Okay. So because we are using diametrical coordinates as we already selected here in the simulate option in detail settings, we have checked on diameter coordinates. So we have to specify everything in the diametrical terms. Actually, it is only for x coordinate. The z coordinate is as usual. So x32, because 32 is the diameter of this workpiece, it will actually move the pointer from the origin to the periphery of this workpiece, and there's nothing else to change here except the x coordinate and the z coordinate, because the y coordinate actually goes out of the plane. It is actually coming out of the screen, and so we are only interested in x coordinate and z coordinate to do the turning process. The y coordinate will be 0 all the time. We will specify z as 2. See, the origin is located at the center. So if you specify z2, it will move away from the workpiece. So the tool will slightly be offset from the periphery of the workpiece in the z direction, and it will be like it will be aligned with the workpiece, but at some distance in the z coordinate. I hope you're able to imagine this. Now, the next line would actually start the process. G01. G01 means we will slowly move the tool as per the feed rate we have mentioned towards the workpiece or away from the workpiece, whatever. It depends on the coordinate we're specifying. So we'll move it at x30, x31. So in one pass, we are aiming to reduce the diameter by 1 mm, and we'll make z as 0. So by writing this code, we're actually placing the tool somewhat below the periphery, and the tool is in contact with the circular end face of the workpiece. So the tool might be located somewhere here below this periphery at this position, but it will be in contact with the circular face of the workpiece. Now we will again write G01 because we are doing the process. We are doing the first pass of turning operation. The x coordinate won't change. We are just changing the z coordinate. We'll be moving from, like, right now this the tool is located somewhere here, and we want to move it like this in the first pass. So we won't change x because x is like this and z is like this. So we'll just change z and make z as -70, because we want, let me show you the diagram. We want a 70 mm of length from the end face to be reduced to a diameter of 28 mm. So we would specify z as -70 and G01. This would move the tool from this somewhere from this location to somewhere, let's say this location, and the diameter for no the diameter will reduce to 31 mm. So now we have moved the tool here, and the diameter has also been reduced to 31 mm. Now what we want is, we want the tool to come back to its previous position. So what we do is, we first move this tool in the x coordinate. We won't change z coordinate for time being. We will move the tool as per the feed rate in the x coordinate, and make sure that it again is 32. So it will again go here, somewhere here. Now, because we have moved the tool and it is no more in contact with the face of the tool actually, so we can just rapidly move the tool to the location where we want, and just start the process again. So we'll just change the z coordinate to 0. So the tool will now move from here to here rapidly. Got this. Now we will just again, right now this the tool is located here. Okay, so what we'll do is, we'll just slowly move the tool. We'll just change the x coordinate and make sure it is x 30. So now we have increased the depth 30, and we will again form the second pass, and this goes on like this: g01 z minus 70, and g01 x 32. We are using g01 here, like g01 x 30, because we are actually, the tool is will be in contact with the workpiece. So we make sure that it is going with the feed rate g01, and while we move this tool from this end to this end, it has to move in accordance with the feed rate. That's why g01 here z minus 70. And again, when we are lifting the tool from this point to this point without changing the z coordinate, we again, the tool will be in contact with the workpiece. So we just write g01 here, so that it does not move rapidly to this point. Once the tool has came I mean reached here, we want the tool to move from this location back to this location. So we'll just use d00, which is rapid repositioning, because the tool is not in contact with the workpiece anymore, as we have lifted the tool up. So he will mention z0 without changing the x coordinate. So this would go on further, that it is now very easy to write the codes from this point onwards. So I will just write it uh, and complete this code. So after this code, the pointer is actually here at the top. I mean at x equal to 32. And now you'll just again write g00 and z0. So the pointer comes, the tool depth is located here at this point right now after this code. Now, having said this, the process is actually completed, but we are required to stop the spindle. So we would type M05. We also need to stop the coolant flow. So the code for the same is, uh, just a minute. The code for the same is M09. So we would type M09, and to end the program, we must type M02. So this ends the code, and now we are ready to run this code. So just click on this icon here, and if you want the code to execute step by step, you click this uh, go on clicking this, and you would just see the process happening step by step. And if you just want to see the process you know as a whole all at once, you just click here and it will do it for you. So this is how we do the step turning operation as we have seen in this diagram for this part, using the absolute coordinate system in CNC simulator. The same can be done with incremental coordinate system.